Hello, everyone. Thank you for joining me for this webinar on Enable Business Agility through Database DevOps. My name is Esteban Garcia. I'm the founder and Chief Technologist at Nebbia Technology. I'm a Microsoft Regional Director and a Microsoft ALM MVP, Pulitzer author, and also part of the Friends of Redgate uh, group. You can see my contact information, my email, my blog, and also my Twitter handle. So feel free to reach out to me with any questions afterwards, or if you have any, if you just want to say hi. So today's webinar is hosted by Redgate, and about Redgate, in case you don't know them, I'm sure most of you do. Redgate's been around for 19 years, so it's a very well-established company. And one thing that I love about Redgate is that not only are they building and selling amazing DevOps tools, but they're living that DevOps mindset. Just this year, they've released 582 times to production. Redgate's used by 91% of Fortune 100 companies, and they like to drink a lot of coffee, so they drink 100,000 cups of coffee each year. So anyways, Redgate's a great company to work with, and they make amazing tools to support your DevOps transformation and general database related things. So today we're going to be talking about, like I said, how to enable business agility through database DevOps. And let's talk about why do we need this. So the business case for this is that your company might have just really long deployments that are costing you money. And some people ask me sometimes, like, what do you mean by that? Well, if your deployment's taking a month, 2 months, 3 months, or a year, in some cases, I've been in places where they have 18-month deployments, is that they've built software that's just sitting on the shelf, and that software that's sitting on the shelf is literally software that you're letting go to waste. The thing that you built many months ago, it may no longer be effective, or it may no longer apply to what your company is trying to do. So, and because of that, you don't get enough feedback. You're getting something out to your customers, and by the time they get it, they're like, "Yeah, you built the wrong thing," and you've spent so much time doing this. You've spent so much time building the wrong software that by the time you get it to them, you've wasted a lot of time on money. A lot of practices that we see along the way lead to silos, meaning we might have a development team here sitting on the left, we might have the QA team sitting in the middle, we might have the operations team sitting on all the way to the right, and they sort of throw things over the wall. And by doing this, now we're not able to collaborate. We're not able to implement the tools that allow your team to deliver value to your customer. The other thing the other use case or business case for us to be able to start thinking about database DevOps as the thing that enables your agility is that a lot of companies that we work with, they are furiously working towards getting to a zero downtime deployments. These zero downtime deployments, they take a lot of time to get to the point where you're like, hey, everything's working. But then we realize that, oh wait, we got the application, we got the API, we have all the components thought about, but then we can't do zero downtime because the database gets in the way. And by thinking about the database as part of your DevOps process, you're able to make the database part of your zero downtime requirement and deployment. The other thing that we see quite a bit is that in order to be able to deliver value to your customers, in order to be able to develop using real world scenarios, you're going to need some production data. But we don't want that production data living in development. We don't want my social security number living on a developer's machine, my address, my real information. But we want to make sure that that there's some data that represents production is able to make it to development. So how do we make that data available to developers, to testers, to UAT environments in a way that's secure to your customers, safe for you? So those are things that we think about whenever we are whenever we talk about enabling business agility through database DevOps. So as we go through the next 45 minutes or so of talking about this, I want to remind you that there is a way for you to post questions on the chat. So if you have any questions, just post them in the chat. We'll have some time at the end of the webinar to answer some of your questions. But yes, any questions you may have, feel free to post them, and we'll get to them. All right, so I'm going to talk to you about a case study on a company that we work with. Where we're trying to enable zero downtime deployments. As a company, my company, Nebbia Technology, we do DevOps transformations, and we enable Azure and just overall cloud thinking. And in order for this company to be able to achieve that, we wanted to achieve zero downtime deployment in order for this company to take a full advantage of the cloud. And really part of their DevOps transformation was, hey, our goal is to be able to deploy anytime in the middle of the day, in the middle of the night, or just, hey, we're going to launch, let's deploy. So this is a company with about 4,000 employees, over $1 billion in revenue. There are about 50 developers supporting this, and their primary technologies was .NET and SQL Server. The problem was that their deployments just took 5 hours. They had a weekly window of 5 hours where they could deploy. This weekly window, they're here in the United States, they're in the Eastern time zone. They have customers throughout the world, though, so they couldn't just say, well, we're going to deploy at midnight or at a sensible time, even 10 p.m. whenever their company closed. They're basically running a 24/7 operations. So their deployments happened on Saturday mornings, the US time, at 3 in the morning. And they went from 3 in the morning to 8 a.m. Their deployments meant that about 8 or 9 people sat on one big table, and they walked through the deployment manually to try to make sure that we deployed correctly. I don't know about you guys, but I myself, I am not very alert on Saturday at 3 in the morning, nor am I very proficient with what I do. So just the scenario of deploying at 3 in the morning on a Saturday already leads to some risk. Because of this, people didn't want to be up at 3 in the morning every Saturday. Plus, since we were deploying so much, their deployments were pretty risky, and most of the time, something broke. So to mitigate that risk, they decided, hey, we're only going to deploy every 3 months. Actually, they were deploying every week, every month, but their changes, their cycle time took 3 months. So from the moment I wrote a piece of code, a line of code, or I made a change to the database, those changes never made it to production until 3 months from now. So that meant that they had 8 different releases in the queue. So I'm done with my code, everything's been tested. Oh, I have the package ready to go, but we're gonna queue it up, and we're waiting in line. We're 8 releases behind. If I made some code changes today and I want to get it into production tomorrow, I can't because I have 7 releases ahead of me. So the first thing that we wanted to make sure that we had very well defined at the organization was, what is DevOps? What are we trying to do with DevOps? The initial phone call was, hey, we need DevOps because we want to automate all things. That's our whole goal. Let's give us a bunch of tools, give us a bunch of just PowerShell scripts and SQL scripts, and just automate everything for us. And taking a step back on understanding what DevOps is about, understanding that DevOps is the union of people, process, and products to enable to continuous delivery of value to our end users was a big deal. So really understanding, why are we doing this? Why are we writing all these scripts? Why are we trying to automate all this? What is the end goal? And the end goal is to be able to get people working together, collaborating together, implementing processes that enable that collaboration, finding where those processes are broken or where those processes have bottlenecks, and then only then implementing the tools to enable all those processes, and implementing the tools that allow people to now start delivering value to the customers. At the end of the day, your customers are the ones that are going to be mostly affected by your changes. We also wanted to make sure that we had a very clear understanding of what we meant by cycle time. Whenever we wanted to say, we want to shorten your cycle time. Your cycle time is 3 months. Well, what does that mean? What does it matter? Well, we want to make sure that everyone was on the same page of cycle time being how long does it take from the beginning of the work until the results are used by the customers. The problem was that cycle time before was being defined as when did I start working and then when did I finish that work. And that gave us the wrong sense of reality, if you will. We wanted to be able to make sure that our work made it to production, and we wanted to be very clear about the fact that we wanted to shorten that time from the moment a customer requested something until the customer saw that change. So now cycle time was very well defined into the moment I get that work assigned to me until that work actually makes it to production. I'm no longer building potentially shippable code. Now I'm thinking about how do I ship that code and those database changes. How do we shorten that cycle time? We think about smaller batches. We no longer think about, hey, I'm building this one big solution that's going to require 100 table changes and store procedures, and I'm going to require 5 different .NET solutions. But I'm going to work in smaller batches where for this one change, I'm going to make maybe 2-3 table changes, and I'm going to make some code changes. Okay, let's get that out to production, and then rinse and repeat and keep going. We enable automation, and that allows us to start releasing more frequently. I no longer release once a month or once every 2 weeks or once every 3 months. Now I want to be able to release every day or every week at the latest, and then I'm able to, because now my releases are they're less risky than they were before. They're less complex. It's no longer a five-hour release because I'm releasing less things. The other thing that I wanted to make sure that we had a good understanding on is, what do we mean by continuous delivery? Sometimes when people think about continuous delivery, they're like, whoa, we can't do that. I can't have just a developer check in code and that code makes it all the way to production. So whenever we think about continuous delivery, is the entire process from building to testing, configuring, and deploying from a build to a production environment. That may require some gates, some manual approvals. That may require someone to do some manual processes. Maybe we're running a SQL script manually. Maybe we're just at least inspecting the SQL script and then letting the tool run it for us. So really, whenever we think about continuous delivery, is how do we go from my code check-in all the way through production in a repeatable and way that meets your auditing requirements. To be able to get there, we use a release pipeline. That's what enables us to deliver to multiple environments. We want to make sure that we practice our deployments across many different environments. That way, whenever we're ready to go to production, it's just like, hey, it's Wednesday afternoon, and we're going to deploy to production right now because we can. Or, hey, we're going to go to launch, so I'm going to go to production, and then I'm going to go launch, and I'm going to watch the deployment from my phone. That's what we want to be able to do by implementing release pipelines and allowing you to practice your deployments throughout your the release or your development cycle. It's really important for your release pipeline to include code, infrastructure, and database. So we no longer just think about, hey, I want to be able to deploy my code out there. Okay, now DBA, go run the scripts. Or, hey, before we deploy our code, I need someone to go and click around, whether you're using AWS, you're using Azure, or you're deploying on premises. I don't want someone to go and click on buttons or enable new infrastructure. I want the infrastructure to be created automatically along with the database, along with my code. That's where a true robust release pipeline does for you. It's also important to be able to develop feedback loops. So we want to be able to get feedback from the customer early and often. Am I building the right thing? Am I building the thing that you're going to use? Am I building the thing that's going to solve the problem that you have right now? We also want to define feedback loops as feedback from internal processes. Hey, I just made a change to this one database. We have some unit tests or database unit tests or code tests or integration tests, and my test just broke. I want to know that right away. I want to make sure that my internal systems Give me this feedback again early and often, so that I don't build the wrong thing. I don't build something that's broken. As the process goes on, you want to shorten and amplify those feedback loops so that you can make any changes continuously. You don't want to wait until the end. If you're following Scrum, for example, we don't want to wait until the end of the Scrum or the end of the sprint to say, okay, now let's take a look at all the bugs and let's fix them. We want to know about all those security issues or unit tests, broken tests, broken integration tests, load tests throughout the process. So by the time we get to the end, we're able to deploy. So we're shippable all the time. We're able to get some feedback from our software, or we also want to be able to get feedback from our internal stakeholders. So all those are valid feedback loops. So where does the database come into all these things? A lot of times teams, they focus on code. They say, yeah, we are fully automated. We have the CI process. We have this continuous deployment, and we just push a button and everything just happens automatically. And then my question goes to, well, okay, what happens to your database? Typically, not every single application, but typically applications have a heavy reliance on the database. So the database has to be thought about whenever you're implementing these processes. So what happens a lot is that because of that, even though we might have automated everything and we don't automate the database part, now we still have a longer deployment time, and then we don't have a manual repeatable process. We might have a process where I email a script to my DBA and someone else copies the script to a folder and someone else just sort of runs the script themselves or uses the IDE to make changes to the schema, and then you leave it up to someone else to figure out how to recreate that script. So that's where database DevOps, the concept of database DevOps comes in. That's what we want to start embracing, to make sure that you're able to think of your application as a full system that encompasses not just the code, but also the database and the infrastructure, and think about how can we get all that streamlined. So the goals with this engagement that I'm talking about was to, hey, we want to streamline our deployments. We want to make them faster. We want to make them remove any obstacles or any clutter. We want to make sure that our code and database changes are aligned. If I'm releasing code version 1.5 that supports database version 1.4, then the two of them should go together. If I'm releasing a new version of the database version 1.5, and my code is going to break with that new version, I need to make sure that they both go together. So we start aligning them and we start thinking about those two as components, just like you would on the code side. Hey, we just added a dependency on a new version of Entity Framework. Well, your code and Entity Framework DLLs need to go together, otherwise things are going to break. You want to think about database in the same way. We also wanted to make sure that we enabled refreshes, data refreshes. Developers were working with very stale versions of database and also the very stale versions of data. That meant that everyone had their own secret script that they ran to be able to get the database in a state where they were able to test things. And that just became a little risky and just time consuming. We wanted to be able to enhance our feedback loops. We wanted to make sure that people were able to get versions of the code so they could start testing it both internally and also in front of our customers. And we wanted to be able to start delivering continuously. Our goal was to be able to deliver on a daily basis with zero downtime. At the end of the day, this is what we're trying to achieve. We wanted to be able to go from the developer machine. We wanted the developer to store their code in version control. We wanted to make sure that every time their database changes went into version control, we kicked off a continuous integration build that took the database changes, they packaged them together, passed them off to release management server, and the release management server was able to deliver to different environments. In our case, we're using Azure DevOps, which is formerly known as VSTS, and Azure DevOps integrated with Redgate's tools allowed us to have this entire pipeline and all these capabilities. You're really able to use this with many different tools out there. So as we started going down the path of, okay, we want to make all these, we want to enable all these new capabilities. Our first goal, we couldn't get started down this path unless we had a single source of truth. Meaning, we wanted to have one place where all our code, all our database, and our infrastructure lived, and we knew that if someone new started tomorrow, all they had to do is get latest and go, right? The problem was, one of the problems was that if someone new started tomorrow, took about 3-4 days for them to be able to get started, because they got latest from something. They had to get a backup of the database. They had to apply the secret scripts that I talked about. So that was not very sustainable. So there was a code and database mismatch. If I got latest and then I took the backup of the database from someone's machine, now they didn't match, so the application didn't work. It was really difficult to track scripts. Like I said earlier, each developer was writing their own schema changes scripts. They were writing their own data insert scripts, and then they were sending it off to the DBA, who was sort of keeping track of them. And then at the end of every, when it was time for a release, they had to package all those scripts by hand, hopefully putting them in the right order. Every time someone got latest, their local environment broke. Why? Because we were only storing the code in version control. So if I made some changes to my local database, my local version of my database, to support some code changes, and then I checked in the code changes, and then the person sitting next to me got latest, guess what? Their application broke because it relied on my database changes, and they didn't get my scripts yet. And like I mentioned there, it was really challenging to onboard new developers. So to be able to achieve that goal, our solution was to introduce Redgate's SQL Source Control. That allowed us to start collaborating more. So if I made a change, I'm able to get that into version control. I'm able to do a pull request to get someone to do a code review on my changes, both on the code side and the database side. And then multiple people can start working together, having their own local copy of the database. They were able to start sharing the changes easily and much more effectively. Now we achieved having version, our code and our database, they were both just living in the same repository, being part of the same process. If I got latest of both the code and the database, and I could keep going. So now my mismatch went away. This increased velocity quite a bit. Now we're able to just go, and then at the end of every release, or at the end of every sprint, we're able to just take the one package that took both the code and the database together and get it released to the next environment. So with SQL Source Control, it integrated right into our SSMS tool. And from here, we're able to take our database, link it to Git in our case. Anytime we made any change, the SQL Source Control was able to script out that change. Hey, in this case, we added a new email field, and then when we added a new email field, I made it part of the deployment package that got sent to the next stage. It also meant that next time someone got latest, they were able to get this change, and they were able to keep going with the code changes and their database. The next goal was to have automated database deployments. So not only did we want to make sure that we could automate our code deployments, we wanted to make sure that we were able to automate our database deployments. Now we had our database in version control, but it was still a manual process to be able to get these changes out, which meant that we're still far away from achieving zero downtime. Our code deployments were pretty automated. We had been working on that for a while. They actually had that working pretty well. We helped them with streamlining it, but where we wanted to make sure that our database deployments were no longer manual. We're way over reliant on those manual processes, which also meant that if someone took a day off or a week off, we couldn't do deployments that week, because that was the one person that knew the secret on how to align all those scripts together in the right order. Otherwise, we knew we were gonna be the application wasn't going to be working. So this meant that we couldn't achieve zero downtime. So our solution to that was to implement SQL change automation. So we were able to start implementing the ability to package changes together and then release them to other environments. So with Redgate's SQL change automation, we're able to achieve that. That gave us a repeatable and reliable process. And that repeatable and reliable process translated into us being able to start getting a little closer to getting to zero downtime. Why? Because now we had much less deployment problems. No, they didn't go away magically on day one, but that took us down the path where we were able to start reducing those problems. Now that this gave us the ability to start deploying more often, and now it reduced downtime because now we're not waiting for someone to click buttons or do their script. We had a repeatable process. We had a way to practice our deployments over and over and over in the lower environments to get our confidence level much higher. And then with that confidence level, we were able to start deploying more frequently and deploying with less risk, and knowing that, hey, if something went wrong with our deployment, that's okay because we can deploy right away again, right? So that's another one of the benefits of this. As I mentioned earlier, we're using Azure DevOps. So with Azure DevOps, we're able to add a task that let us build and publish and synchronize synchronize our database to different environments. So it integrated really, really well with this. Thankfully, Redgate created a task for our build and release definitions in Azure DevOps that allowed us to just leverage that out of the box, which is great. The next goal that we had is that we wanted to make sure that developers and DBAs and everyone that was doing any work around delivering value to our customers was able to develop using real data. As I mentioned earlier, databases and data became pretty stale. So because of that, it was difficult for us to be able to move fast, and also sometimes there were some edge cases that were not tested, and then when we got to production, we found out that something broke. Because of that, developers and testers were having to just create their own scripts to be able to fake some data. And one of the problems that DBAs told us that was causing their lack of ability to give us constant refreshes, that data refreshes just took too long. We're dealing with a database that was like 2 terabytes in production, and that 2 terabytes database refresh just took a long time to be able to make it available to everyone. In addition to that, every developer wanted to have a copy of that, and then giving every developer enough space on their own laptop or on their own PCs to be able to work with that was very challenging. So because of that, because of the sheer size of those databases, developers were working on a centralized database. And then developing a centralized database meant that if I went in and made a change to one of the tables, that affected everyone, and I broke the build right away, and I broke everyone's local environment because I made a change to the centralized database. Another really scary and a difficult problem was that production and sensitive data from production leaked outside of production, and we that's not good. That's how bad things happen. So we wanted to make sure that production data stayed in production, sensitive data about production stayed in production. We're okay with bringing down some data from production, or most of the data in production, but when it came down to any type of personal identifiable information, we didn't want any of that data to make it as is into development or testing. So that was one of the problems that we wanted to try to solve. So how did we solve that problem? We introduced Redgate's SQL provision, which is SQL Clone and Data Masker. With SQL Clone, you're able to configure an image of your production database, and then make clones out of that. And then as part of Data Masker, you're able to take that database and pass it through a process that was going to take your data and sanitize it for you based on your own rules. This allowed us to streamline the data refresh. And if I needed a new environment, it no longer became this thing where like, oh my God, we have a new environment. We need to go and create a new space somewhere with enough space for 2 terabytes worth of databases. Well, we need 10 environments. That's 20 terabytes. That's a lot of space. Also, it removed the bottleneck, right? Earlier, if I needed a new database refresh, I had to put a request into the ticketing system. Eventually, the DBA got to it. It was not the highest priority, so eventually got to it and then gave me this environment. I am now able to go push a button and say, hey, I need a new one of these environments, and it's been approved. It's already been sanitized by someone. By the time I get it, I don't have to worry about which table should I not look at or which table should I run a script against. This lowered the data security risks by a lot. Now everyone was able to start just using these databases, knowing that someone that had security in mind already created the scripts that ran through the database and sanitized the data, removed either scrambled names and social security numbers and date of births, or applied a rule where whatever your data security practices told us that we should follow. This also allowed us to have a dedicated development and test databases. This was huge. This was it was somewhat so we knew it was going to be helpful, but it was what we saw, the amount of uh, the, the amount of pain that this removed was beyond what we thought we're going to solve here. So now every developer was able to start having their own copy of the database on their own machine, and by doing this, they were able to start delivering and developing faster. They were still using SQL Source Control, but now they were using SQL Source Control with a clone database, and then they were able to move faster. And then we were also able to give test environment, create more test environments, and it streamlined things quite a bit. So what we ended up having is basically this. We have with SQL Clone, what you do, and for those of you that don't know what SQL Clone is, you're able to create an image based on a SQL Server backup or from a live SQL Server database. You create an image. That image, in this case, a 4 terabyte image, then you're able to create a clone, and that clone is basically a diff file that it's a fraction of the size. So typically for obviously your hardware and your network it's gonna depend on some of this, but I've taken a 2 terabyte database and I've cloned it within less than 2 minutes, and then when the time it gets cloned, it's 200 megs or so, and then I'm able to take that 200 meg database and just add it to my SQL Server and start using it. I'm able to clone it into my SQL Server using from a Management Studio. When I'm in Management Studio, it doesn't look or feel like it wasn't a SQL Server database. Behind the scenes, our good friends at Redgate have done all the magic to make sure that your database it just works. Anytime you make any modifications to the database, that new clone is going to keep track of those changes, whether you're doing schema changes, whether you're adding new data, but then it's all going to refer back to the image, and that image it's not going to touch your production database at all. At that point, once the image gets connected, once created, it's completely disconnected from the source, so you don't have the risk of touching anything in production. So it's very, very powerful. It's a great way to be able to work with production databases in other environments. As part of the cloning process, we worked with Data Masker to be able to apply rules on the data that's coming in. So rather than saying, okay, well, we cloned it, now let's add Data Masker, the moment that we're creating our image, we added some rules to go ahead and apply that masking. So by the time someone's going to use that clone, they don't have to worry about security. Someone else took care of it. Someone that owns security took care of making sure that the database was not has the right data. Our other goal was to be able to test our deployments against production. So one of the things that that we ran into in the past is that right when we got to production, maybe a SQL script wasn't created quite right, or we wanted to make sure that we knew what the impact of our changes were in production before we flipped the switch. It was a little bit difficult to do before because, like I said earlier, with such a large production database, it took hours to do our backup and restore. That meant that we had low confidence in production deployment because some of the errors that they had. There's some edge cases. Even there's so many transactions happening in these databases that even if I'm working with a brand with a database that was restored a week or two ago, I might run into some edge cases. We wanted to make sure that we knew how to what the impact of our changes would be. We also wanted to be able to load testing, and load testing against real production-like data was really, really important for this customer. So how did we get there? Well, our solution was SQL Clone again. So with SQL Clone, we were able to pre-deploy to staging before a production release. So our pipeline, our build and release pipeline, included us taking an image from production and then creating a clone from the image and putting it into our staging environment. Once we did that, then we applied our changes to that clone, and then we saw what production was going to behave once we went live. That would have taken so many hours before. Now we were able to achieve that fully automated within like 30 minutes. We had the clone, the deploy, and then we ran through our load test. So it's pretty powerful way for us to get a lot more confidence in our deployment. And then this allowed us a way to practice our deployment. Like I said earlier, one of the biggest reasons why they deployed not often enough is that the confidence level in deployment was really low. The business did not want anyone deploying to production because every time we deployed, we broke something. But they wanted more deployments because they wanted to add more value to the customer. So they were in this weird catch-22 scenario. So now, after doing all these things, we talked about all the problems that we had earlier. Now, code and database, they both live in source control. Developers are able to, with confidence, bring down just one pull from Git, and they get the database changes and their code at the same time. They're able to define, and they have a fully automated release pipeline. There's a path for me to follow. I know that whenever I check in code into version control or I push code up to Git, that code has a path to production. And the path no longer involves having a bunch of people doing some manual things. The path involves having a repeatable process. Our releases now take less than 1 hour. They used to take 4 to 5 hours. Now within 1 hour, from the moment we say we're going to release until everything is out in production, including some approvals, it takes less than 1 hour. We're still working on it. Our goal is to be for the release to be less than 15 minutes. We are now at zero downtime. We're able to deploy early and often, and we're able to deploy any time during the day. And now we have production databases available for testing. And when I say production databases, I don't mean production with all the production data. I mean all the data, all the rows are there, but we have masked the data. We've made sure that security is first and foremost in our process. We don't have production databases just laying around the people's laptops or around the network anymore. We have one clone, and we have one image, and that image is already masked, and then people are able to self-provision clones as needed. Our process involves basically from the moment a developer makes changes, they get into source control. That source control check-in or push triggers and continuous integration build. That continuous integration build triggers a new release that goes into different environments, testing, QA, staging, and then production. But we don't go into any one of these environments until someone approves it. So someone approves something going into testing, and then into QA, to staging, into production. Thanks to all the different Redgate tools, we're using SQL Source Control, SQL Change Automation, SQL provision as part of our entire process. So how do you start? So people ask me all the time, it's like, what? Okay, that's a lot of things going on here, but where do I start with all these changes? You talked about a lot of tools, you talked about a lot of different processes. So first, measure is one of my top uh, recommendations. So you want to make sure that you know what is it that you're trying to achieve, right? So if we say, okay, in order for us to be able to get to know that we're successful, what are the things that we're looking at that will tell us that we were able to succeed? And as part of that, you want to have a plan, right? So you could measure everything, but not everything is going to tell you whether you are successful. So start by measuring and measuring the things that matter to you. Automate. We want to make sure that we're able to automate as much as you can. Remove manual processes from your process. Make sure that everything is part of everything's automated, and you're able to uh, just streamline as much as you can. You just want to define your feedback loops. Who do you want to get answers from throughout the process? Who do you want to make sure that your customers see something? Do you have a specific subset of your customers that should see that should see your changes throughout? Are there any internal stakeholders? So that's on the application side of things. We also want to make sure that we know that. How do you know that your code is healthy? Define what a healthy pipeline looks like. Define how do we know if something's broken. So things like code coverage and number of test cases, integration tests, load tests. So define what those are and implement them. Always learn. Always uh, look at what you've implemented. Pause. See, okay, is this better? Are we going down the best path? How do we get there? So make sure that you're stopping to learn all the time. So with that, hopefully you guys enjoyed that, and you guys were able to get some good information from there. I do have some questions that came in while I was talking here, so I'll just read them out, and then if anybody else has more questions, I'm happy to answer them. So the first question is, do the cloned databases functions fully? Can I develop on them and commit changes to source control from them? So yes, clone database to SSMS and to SQL Source Control, it's just another SQL Server database. It knows nothing about the clone being behind the scenes. If I look at the metadata of the SQL database, it'll know that it's a clone, but behind the scenes, Redgate's doing all the cool things, magic or just some great technology, really, to make it happen, to make it look and feel like a real SQL Server database that is really just a diff file for the image. So yes, you're able to do all the things that you do right now with a regular SQL database using a clone. We've used it very effectively. The next question is, can I use Redgate's CI/CD solution if I have some developers working on SSMS and some working in Azure DevOps? So yeah, yes, you can. I think that's where you have a couple of different options. So if everyone's going to be working only on SSMS, then you want to use the SQL Source Control model. There's also something called Ready Roll, which I didn't cover here, which is where if people are using more on the Visual Studio side of things, they might be more comfortable with. One thing that you can do is that you can have people making changes really anywhere. So let's say that you make your changes you make your schema changes in Visual Studio, or you make your changes wherever you you make them through, let's say, Entity Framework, for example, and then you can jump out to SSMS and then commit them from there, right? So you sort of have to pick your strategy. You having everyone sort of working on both sides of the equation makes it a little bit tough. So I would say pick the strategy that's going to work for your team, whether you go down the ready roll path or you go down the SQL Source Control path. That you want to establish that first. All right, next one is if the deployments are fully automated, what mechanism is there to prevent a bugged build being deployed to production? Is testing part of the pipeline, and will a failed test stop deployment? Yes, automated tests are very, very important. So there's a couple of things. First, yes, you want to have automated tests throughout the entire process, whether they are part of your CI or part of your deployment process. So there are some things that you'll be able to run as part of CI, things like unit tests, whether they're database unit tests or they are code unit tests. Once you get past the continuous integration build, you would have things in your release pipeline like integration tests or functional automated tests. You can also have some manual steps. You can say stop right here, go and run your all your manual tests, and then once everything looks good, you approve it, and then you go. Now, if that buggy deployment makes it all the way to production, it's typically two options. You either find a way to roll back, or or the way that we typically like to approach things is you find a way to roll forward. Rolling back can be just as risky as keeping the bug out there. So by you having this automated pipeline and streamlining the process, this gives you the confidence to say, well, okay, if something went to production that's broken, it's actually less risky for me to fix it and get it back into the pipeline, and we know that we're able to release so quickly that that's going to be the most effective thing to do. So, your processes are still going to be part of this. So just because we have a automated deployment process, it doesn't mean that we're throwing quality gates out the window. So you would still have, yes, you would include tests along the way to make sure that you're ensuring quality. All right, next one is it possible to have an automated pipeline that includes the database and the application code if they don't always need to be released to production together? For example, if we want to release application code daily, but databases change only weekly, we have been delaying including the database in CI/CD because we can't break our database development work down into daily releases to keep up with app code. Okay, so I would say that this may be a branching strategy discussion. So if you have some changes in the database that are not going to be compatible with the database code, with the application code, I would call that out as a separate feature. If you are whether you're using Git or TFVC or SVN or whatever version control system you're using, I would say maybe you can have your database changes, the longer running changes, on a separate feature branch. And then you can have your code changes that are not related to the database changes in a separate branch. You're able to deploy your code changes daily on their own branch. And then once your database changes are done, the weekly ones, then you can merge them in with your code. Now, along the way, I would merge up your code changes up to where your database changes are. That way you're integrating often. But that would be, I would just treat it as any other change, right? If I have two features that I'm developing, I would also separate that into two separate feature branches and treat it the same way. So that's how I would go there. So rather than you delaying your code releases, treat it that way. And then, start thinking about, okay, maybe think about how can you get your database changes down to smaller chunks, but this might be a good way to start. So I don't see any other questions, but people can, if you have any other questions, feel free to email them at devops@redgate.com. I'll also post my my email that I already posted up there. It's just Esteban@nebbiatech.com or through Twitter, whatever's easiest for you. Happy to answer your questions. So I'd love to hear any other questions that you may have. Before we wrap up, a couple of things that I wanted to point out. So first, Redgate is so you're having a SQL in the City streamed on December 12th, 2018. So SQL in the City just finished, I believe it's a 3-city tour. I was they were in London and New York and Chicago. I was actually up in Chicago. I joined Redgate up about a month ago. But they're doing one more, which is the streamed version of SQL in the City, December 12th. You can just follow that link, redgate.com/SQL in the City to sign up. And then finally, we have the 2019 State of Database DevOps Survey. Redgate is conducting this survey. You're able to follow redgate.com/DBD survey. And if you fill it out before November 30th, you're able to win a $250 Amazon gift card. So anyways, this is a great way to understand where is your organization? Where are you in the database DevOps journey? And Redgate uses this to inform the community and help drive this conversation. So with that, I'd like to thank everyone for attending this webinar. It's been great presenting this information to you. Great questions. I really appreciate those. And again, if you have any other questions, feel free to send them our way. Thank you.